You're about to learn how to program in Java from Farhan Haseen Chaudhry. Farhan is an experienced software developer here at Free Code Camp, and he is great at breaking down concepts for beginners. This is a great course if you want to learn Java, and you can follow along with the whole course from within your web browser. Farhan will teach you the basics of Java using Replit. Replit is an online IDE that allows people to write all sorts of programming languages right within their web browser. And Replit provided a grant that made this course possible. So, it's time to learn Java.
Hello everyone, welcome to the Java for Beginners course. I am Farhan Haseen Chaudhry, and in this course, I will teach you all the fundamental concepts around Java. Now, ideally, a programming course usually starts by downloading and installing a lot of SDKs or IDEs or whatnot. But since we will be using Replit throughout the entire course, we don't need to do any of those. Replit is an online collaborative IDE that you can use right from your browser. To start, go to www.replit.com and you should land on the page. You can create an account on Replit, or if you already have an account, just go ahead and log into that. I will just use my Google account to log in. Once you have logged in, you will land on your home page. From here, you can create a new REPL by using this create button. Now from the list of language, we will pick Java, but just so that you know, Replit supports a long list of languages. Make sure you are giving your new REPL some descriptive names such as hello world. Finally, hit the create REPL button and wait until the process finishes. Now, if you have worked with some other code editors such as Visual Studio Code, the look of Replit should not be very different to you. You can change its default layout by going to Settings and Default Layout. By default, it should be side by side, but you can also pick stacked if you like that layout. Now, the default Java REPL usually comes with a bunch of code, and you may have already guessed that this is the famous Hello World program written in Java. To run this code, click on this Run button here, and you will see the code's output on the console. There you go. Congratulations on creating and running your first REPL. On the next lesson, I will explain what's going on. Just before we leave, remember, you can always turn Replit dark by clicking on this moon icon. And if you prefer dark themes over the lighter ones, please go ahead. The Hello World program is probably the simplest executable Java program that you can write. Yet, it's very important that you understand each part of this program. As you may have already guessed, source files in Java end with the .java extension, and compiled bytecodes usually end with the .class extension. To see the compiled bytecodes on Replit, click on these three dots on the Files menu and click on Show Hidden Files. The program starts with a class declaration. A class is a collection of related code in Java. In every Java source file, that is the file with the .java extension, you can have one top-level public class, and that class has to match the name of the source file. This is because if you have multiple classes in your program like this, you will see that the Java compiler produces individual bytecodes for each class. To avoid any confusion about which of these classes is the entry point to the program, the JVM is designed to treat the bytecode that matches the name of the source file as the entry point. Inside the class, there is a main method. Those of you familiar with C, C++, or Go may already know that the main method or function serves as the entry point to your program. The JVM is programmed in a way that it will specifically look for a static method that is named main, has public access, takes an array of string, as a parameter and doesn't return any value. So you will have to write your main method as public static void main string args and nothing else. One thing that you can change, however, is the name of the args array to something like arguments. The array holds the command line arguments passed to the program upon execution. The system.out.println method prints out whatever string you pass to it as an argument. Unlike Python or JavaScript, semicolons are mandatory in Java. So if you leave it out, the program will fail to compile. That's pretty much it about the Hello World program. Don't worry, if you didn't understand all the terms used in this lesson, you will have a much better idea about topics like public and private access modifiers, statics, classes, methods in later lessons. Now, if you try to run the program using the run button, everything works out just as expected. Another thing that you can change is the entry point. This will make sure that Replit opens the correct Java source file whenever you decide to return to this project. Now, there are a lot of other options in this .replit file, but those are not important right now. The Hello World program you have been seeing so far is pretty simple. If you want to write more complex programs, you will at least need some understanding of the different types of data and variables. Variable is any entity that can take on different values. For example, if you want to store your age inside a variable, you can do so like this. First, you will have to write the type of the variable. Age is an integer or int. Then you will have to write the name of the variable, which is age in this case. Then you can finish off by putting a semicolon. You just declared a variable. Declaring means the compiler will know that this variable exists. However, you will also need to define it. You can do so by assigning a value to this variable like this. Write the name of the variable, then an equal sign followed by your desired value. In this case, the equal sign is known as an assignment operator. We'll learn about operator in lot more detail in later lessons. Now, you can print out the variable to the console like this. And just in case you are wondering, using a plus sign is one of the many ways to print out a dynamic value in between sentences. Keep in mind, you cannot use an uninitialized variable in Java. So if you remove this line and try to run the code, the code will fail with the error message, variable age might not have been initialized. Instead of declaring and initializing the variable in different lines, you can do it in one go like this. On the line of declaration, after the name of the variable, put an assignment operator followed by your desired value. Now, if you try to run the code again, see, everything's back to normal. You can change the value of a variable as many times as you want. So if you set the value of the age variable to 28 instead of 27 just before printing it out, you will see that the value has changed in the output. Although you can assign new values to the variable multiple times, you cannot declare the same variable twice. So if you do something like this and try to run the code will fail with the error message, variable age is already defined in method main. If you look closely, you will see two different sets of curly braces in this code. The first set marks the start and end of the Hello World class. The second set is inside the class and marks the start and end of the main method. Code inside a set of curly braces is known as a code block. Since the main method is inside the Hello World class, any variable you declare inside the method will be only available inside the method. These are local variables. However, you can also declare variables outside the method, like here in the Hello World class code block. If you do that, the variable will be available within the entire class. To use this variable inside the main method, you will have to declare it as a static. We will discuss the reason behind this in a later lesson. For now, just remember that a static method can only work with static variables. Moving out the declaration of the age variable and marking it as a static has not made any difference whatsoever. But if you remove the value of the variable and attempt to rerun the program, you will see the program runs without any issues this time and prints out 0 as the value of age. This is because whenever you declare a variable in the class level, the Java compiler will assign a default value to it. For numbers, it's always 0. Now, another thing that I'd like to show you is if you redeclare the age variable inside the main method now, there will be no problem whatsoever because the initial declaration of the age variable is not local to the main method. So, as long as you do not redeclare a variable within the same code block, you will be good to go. When it comes to naming your variables, you can name them anything as long as the names don't start with a number and don't have any spaces in them. There are also around 50 words reserved by Java itself as keywords, and you cannot use any of them either. You can start a variable name with a $sign or an underscore, but excessive usage of these signs can make your code unreadable. In case of multi-word names, always follow camel casing when naming your variables. If you want to learn about different programming naming conventions, I will leave the link to this article in the description. Finally, avoid naming your variables using single letters. Now that you know about variables, we will discuss the different types of data. Keep in mind, I have reorganized the source file to better reflect what I will be talking about. At a high level, there are two types of data in Java. There are the primitive types and the non-primitive or reference types. Primitive types store values. For example, int is a primitive type and it stores an integer value. A reference type, on the other hand, stores the reference to a memory location where a dynamic object is being stored. We will discuss reference types later. There are 8 primitive data types in Java. 6 out of those 8 types deals with different types of numbers. First, there are the bytes. These are small numbers within the range of -128 to 127. Then there are the shorts with a much larger range than bytes, and the integers with an even larger range. If you ever need to store a value so large that it doesn't fit in an int, you can use the long type. By default, any number with no decimal point is treated as an integer by the compiler. To let the compiler know that a number is actually a long, you have to append the letter L at the end of the number. You can also use a small l instead of the capital L if you want. For numbers with decimal points in them, there are double and float types. Doubles are double precision 64-bit floating point numbers with a very long range. Floats, on the other hand, are single precision 32-bit floating point numbers with a smaller range. By default, any number with a decimal point is treated as a double by the compiler. To let the compiler know that a number is actually a float, you have to append the letter F at the end of the number. Like the longs, you can use a small f instead of the capital one here. Boolean data type can have only two values, true or false. At the moment, usage of a data type that can only hold true or false as values may not seem that useful to you. But once you learn about conditional statements, you will see their usefulness. Finally, the character type can hold any valid Unicode character. The Unicode escape sequence for the copyright symbol is \U00A9. So if you store this value in a char variable and print it out on the console, like this we have, you will see that the copyright symbol has been printed on the console instead of the value we have saved. Of course, you can also save any standard character from your keyboard instead of these kind of Unicode escape sequences. For example, if we remove the name copyright symbol and change it to something like % symbol and replace this Unicode escape character with the % sign and update our code accordingly, you will see the percentage symbol printed out on console instead of the copyright symbol. There you go. Now for the most part, when working with integers, the int type should suffice, and for numbers with decimal points, the double type should suffice. But you should also know about the other types. Although you cannot store one type of data inside another type of variable, conversion between the different types is absolutely possible. Type conversion in Java can be either implicit or explicit. When the compiler converts a smaller type of data, for example an integer, to a larger one, like a double, automatically it's known as an implicit or narrowing type conversion. Let's see an example. First, get rid of all the old code in our project. Then begin by declaring a new integer. You can call it anything. Then declare a double. And for the value of the double type, assign number 1, like this. So what you are essentially doing is first taking an integer with a value of 5 and then taking a double and assigning number 1 as its value. Let's try to print it out using the standard system.out.println function, number 2, and run. So as you can see, the compiler has successfully converted the integer to a double. This is because a double is larger than an integer. But what will happen if you try to do the reverse? Let's try out. This time, start with a double. 5.8 maybe. Then an int. Okay, I missed the 2 here. Now system.out.println number 2 and run. So as you can see, the program immediately fails, saying incompatible types, possible lossy conversion from double to int. What the compiler is saying that an integer to double conversion is not possible automatically. Although conversion from an int to a double is not possible automatically, you can still do it explicitly by letting the compiler know that you want this to happen. The cast operator can be of help here. First, inside a set of parentheses, write int. This will tell the compiler that you want to convert this double to an int. Let's try to run the program once again. And this time the program works without any issues. But you have lost the 0.8 part after 5. If you are doing explicit type conversion in Java, be extremely careful whether the type you are converting to will be able to hold the entire value or not. In this case, I knew that an integer will never be able to hold the entire 5.8 value and I will lose the second part, but I went with it anyway. So as long as you know what you are doing, you should be all right. But at any given moment, if you perform an explicit conversion and lose a bit of data accidentally, the results can be catastrophic. Now that you know about variables and the different types of data you can work with in Java, you will have to learn about operators. Keep in mind, I have made some changes to our code to better explain our topic in hand. And since our code has become much longer than before, I would suggest that you go to settings and change the default layout from stacked to side by side, and then hit the reset layout button to apply the new layout. This will give you a lot of vertical space and make the code easier to read. Operators in Java or programming in general are certain symbols that tell the compiler to perform certain operations, such as arithmetic, relational, or logical operations. Although there are 6 types of operators in Java, I will only discuss 4. Bitwise operators are a little bit more complex than the other ones, and I don't think they fit well in a beginner's course like this. We will begin our discussion with arithmetic operators. Arithmetic operators are the ones that you can use to perform arithmetic operations such as addition, subtraction, multiplication, or division, or so on. There are 5 arithmetic operators in Java, and these are the addition operator, the subtraction operator, the multiplication operator, the division operator, and the remainder operator. The remainder operator is also known as modulo or modulus operator. Addition, subtraction, multiplication, and division, these 4 are pretty self-explanatory. You can have a look at our code example here, and you should be able to understand what they do and how they do it. If you have used a calculator in real life, the arithmetic operators in programming work similarly. In our code, we have 2 integer numbers, number 1 and number 2, with the values 12 and 6 respectively. So if you add number 1 and number 2 together, the result will be 18. If you subtract number 2 from number 1, the result will be 6. If you multiply number 1 with number 2, the result will be 72. And finally, if you divide number 1 by number 2, the result will be 2. We will talk about the remainder or modulo operator later. The addition and multiplication operations in this code are pretty simple, but the subtraction and division operation need some more discussion. So we'll get rid of our addition and multiplication code here. We'll comment out the division code and the remainder code and focus solely on the subtraction part. As you can see, the value of number 1 is 12 and number 2 is 6, which means the number 1 is greater than number 2. As a result, the result of the subtraction operator comes out as positive. But if we change the order of the operation here, so if we make number 2 the first operand and number 1 the second operand, you will see that the result of the operation changes from 6 to -6. Again, if you have used calculators in real life before, you should already be aware of this situation. Now, the division operation. Since dividing 12 by 6 yields the result 2, this operation is perfectly fine. But if we change 6 with something like maybe 5, then the result will not be a whole number. As you can see, according to this program, the result will be 2. But if we perform the same operation in a calculator or by hand, we will know that the result of this operation should have been 2.4. Now, this happens because if you divide an integer with another integer, the result will always be an integer. So let's try by changing this integer type to a double. for both operands and run the program once again. As you can see, this time the result is 2.4. But what happens if we divide a double by an integer? Again, the result is 2.4. And if we change the first operand to an int and the second to a double, the result will still be 2.4, which means if you divide an integer by another integer, the result will always be an integer. But if you divide a double or float by an integer, or divide an integer by a double or float, the result will always be another double. Now, let's get rid of our division code as well and focus solely on the remainder or the modulus operation. Now, for this example, I would like to go back to our original values, which are 12 and 6 in the beginning. And I would like to go back to integer. Let's run the program and see what is the output. Compiling a program may take some time, but we just need to be patient here. So as you can see, the result of this operation is 0. First, we need to understand what is a remainder. Now, you may or may not already know that a remainder is the value that remains after you have divided a number with another one. So if you divide 12 by 6, the result will be 2 and there will be nothing left. You can always divide a 12 into 2 6s. But if I change 6 to something like maybe 8 and run the program once again, as you can see, the value has changed from 0 to 4. This is because if you try to divide 12 by 8, there will always be 4 left. I hope you got the idea. You have already seen examples of the assignment operators in previous lessons. It's pretty simple. You can use the equal sign to assign a value to any variable in your code. But you can also combine the assignment operator with the 5 arithmetic operators you just learned about. For example, here we have an integer with the value of 12. Now, if I tell you that you will have to add 5 with this value and save in the same variable, you can do that like this. Now, the output of number should be 17 instead of 12. Very simple. But instead of doing this in such a verbose manner, you can do it far more easily. Let's just remove the second part here. And instead of using the assignment operator, use a plus sign, then the assignment operator, and then 5. This small line of code is actually equivalent to number equals number plus 5. Let's comment this out and see if this gives the same result as before or not. Yeah, 17. So you can use all the 5 arithmetic operators similarly. Say, for example, if you want to take out 6 from 12, you can do so by saying number minus equals 6. And this will turn the value of number from 12 to 6. There. You can also do modulus operation like this. Like if you say modulus equals and then 2, the result of this operation is 0 because when you divide 12 by 2, there will be 2 6s as a result and nothing left. I hope you got the idea of using assignment operator with all the 5 arithmetic operators, and I would suggest that you try out usage of the other ones like the multiplication sign and the division sign with the assignment operator by yourself and see how the result varies from time to time. So far in this course, you have learned about the arithmetic operators and the assignment operators. The arithmetic operators usually lets you perform different types of arithmetic operations on your numbers, and the assignment operator usually lets you assign different kinds of value to variables. Relational operators, on the other hand, usually check the relation among multiple operands. By relation, what I mean is, for example, in this code, we have two integer numbers, number 1 and number 2, with the values 12 and 15 respectively. Now, you may want to know whether number 1 or number 2 is equal to each other, or maybe number 1 is greater than number 2, or maybe number 1 is less than number 2 or not. These are the relation between these two numbers. So in Java, there are 6 types of relational operators. The first one is the equality operator. Now keep in mind, each relational operator in Java or in other programming languages as well usually returns true or false as a result of an operation. For example, on line 7, I have written system.out.println number 1 equals number 2. The usage of this double equal sign here is the equality operator. Now, if I run the code, since the value of number 1 and number 2 is not equal, the output will be false, which is correct in this case. Now, you may also want to check whether number 1 is different from number 2 or not. For that, you can use the not equal to operator. Instead of putting two equal signs side by side, you will have to put an exclamation sign followed by an equal sign. Now, if I run the code again, you will see that the second operation gives us a true, because indeed number 1 is not equal to number 2. Then you can also use the greater than operator to check whether number 1 is greater than number 2 or not. Since 12 is smaller than 15, the output of this line will be false. There you go. There is also the opposite of the greater than operator, which is the less than operator. And this operation in this case will give us true because number 1 is actually smaller than number 2. Finally, there are the greater than or equal operators and the less than or equal operator. Now, the greater than or equal operator will give us true only if number 1 is greater than number 2 or equal to number 2. The less than or equal to operator, on the other hand, will give us true only and only if number 1 is less than number 2 or equals to number 2. Since number 1 is actually less than number 2, the greater than or equal operation will give us false, and the less than or equal operation will give us the result true. Now, the usage of these relational operators may not seem that much fun to you at the moment, but once you start working with things like relational statements, you will start to understand how important these operators are. The logical operators in Java or in programming in general lets you make logical decision based on multiple conditions. For example, imagine you are writing a program that can only be used by people within the age limit of 18 years old to 40 years old. Here, we have an integer number with a value of 25. Now, we will have to make two checks. First, we will have to check whether age is greater than or equal to 18 or not. And then we will have to check whether age is less than or equal to 40 or not. So you have already learned about the greater than or equal and less than or equal operators in the previous lesson. Here, I will teach you how you can combine these two operators using a logical AND operator to make a connected decision. Okay, so let's write system.out.println because we want to print out the result of our operation here, and start with the greater than or equal operation. Age is greater than or equal 18. Then you will have to put double ampersand sign, and this is the logical AND operator in Java. And then age is less than or equal to 40. Let's run the code and see what the output is. As you can see, the output is true here. Let me explain. The logical AND operator in Java or in other programming languages as well works in this way. If the left side of the logical AND operator and the right side of the logical AND operator yields true as a result, then the whole operation will give the result true. Here, the value of age is 25, which is larger than 18, which means the left side is true. And it's also less than 40, which means the right side is also true. That's why the result of this AND operation will be true. But if you change this value to maybe something like 45, which is clearly over 40 years old, and run the program once again, you will see that the output becomes false, because although the left side is true, the right side is not. So in case of a logical AND operator, both sides of the operator has to be true. Now, apart from the logical AND operator, there is also a logical OR operator. Let's imagine another scenario. Maybe you are writing a program for your school's library, and to be able to borrow books from the library, a person either has to be a student of your school or a member of the library. So we can have two booleans here. Is student, which is false. Maybe this person is not a student of your school. And is library member equals true. Maybe he is a member of your library. Now, to check whether this person is a student or is a library member, you can use the logical OR operator like this. System.out.println, and first we will check if this is a student or not. Student. Or unlike the logical AND operator, you have to use two pipe characters to express the logical OR operator. And then we will check is library member. I hope you remember that in order for the operation to be true, in case of a logical AND operation, both sides of the operator had to be true. But in case of the OR operation, if either side of the operator is true, the entire operation will be true. So as you can see, although is student is false, given is library member is true, the operation gives us the result true. So if you turn both of these booleans to true, the result will still be true. And the only case when you will get a false result is if both of these booleans are false. Yes, false. Finally, there is another type of logical operator in Java, which is the NOT operator. The NOT operator in programming usually reverses a Boolean value. For example, here, the value of the is student Boolean is clearly false, right? If we run the program, it will surely print out false. But if we put a NOT operator in front of this exclamation sign, is actually the not operator and run the program, you will see that it turns out as true. So instead of using the not operator over a single Boolean value, you can actually reverse the value of an entire AND or operation in Java like this. Let's go back a few steps. And I hope you remember that in this case, we got the result false because both of these booleans are false. Now, if you put a not operator in front of the is student boolean, this will be turned to true. So now if I run the program, the result of the entire operation will be true. Yes, there you go. The different types of operators that you have learned about so far usually work with multiple operands at a time, except the not operator. It usually works on a single value or variable at a time. Now, these kind of operators that usually work with a single operand is usually called unary operators. Apart from the not operator, there are also two more operators that are unary in nature and very commonly used in programming. These are the increment operator and decrement operators. Assume that you are trying to make a game where you have to store the score of the player and the number of turns left. Now, you can store these values in two different integer numbers, maybe named score and turns. Now, whenever you have to increase the value of score by 1, you can do so by saying score plus equals 1. You have already learned about the usage of the arithmetic operators along with the assignment operator in previous lessons. Well, this is one way to do this. Using this method, you can actually add any number to score. But since here in this code, you will only increase the score by 1, well, you may think that what kind of game that is that gives you 1 in every turn. Well, that's just for the example, okay? Just bear with me. You can do it like plus plus. So putting two double plus signs after an integer or maybe float or double or any number kind out there will increase its value by 1. Similarly, you can put two minus signs to decrease or decrement the value of a number type. Now, if we print out the values of these two variables with system.out.println score, and we will just make a copy of this line and change it to turns. You will see that the value of score is now 1 and the value of turns is now 9. So this is pretty simple. Incrementing and decrementing values, there is nothing fancy until I make it a bit complex. Let me show you something. Let's get rid of all this code and declare a new integer just called number, and maybe its value is 55. Now if I say system.out.println a number plus plus, you may think that this will print out 56 because the you increment 55 by 1 and it becomes 56. Well, let's see if that's true or not. Seems like that the value has not incremented at all. Okay, let's make a copy of this line and get rid of the plus plus and run the program again. This time the value has changed, but at line 5, where you have used the plus plus or the increment operator, the value remained unchanged. But on line 6, where you haven't used any operator at all, the value seems to be incremented. Well, You see, when the compiler reads your code, it usually goes from left to right. So when it comes to system.out.println and sees the number variable here, it immediately prints out its value. So at that point, the value of number will be 55. Then it sees that there is an increment operator here, and it goes like, oh, that means I have to increase the value by 1 as well. Then the compiler increases the value of number to 56 and keeps that in memory. So if you ever print out the value of number later on, it will actually print out 56. Now this is same for the minus minus sign or the decrement operator. Initially the value will be 55 even though the value has changed in the memory, and on the second print statement it prints out 54. So far I have showed you only one way of writing the increment or decrement operator. Instead of writing it at the end, you can also put it in front like this. And let's see what output we get in this case. As you can see, this time we are getting 56 because when the compiler reads your code from left to right, it goes like system.out.println and it immediately encounters the increment operator, and then it sees the number and goes like, okay, so I have to increase the value of number and then print it out. So it prints out 56 on line 5 and on line 6 as well. Same goes for the decrement operator. 54 and 54. So this is something that you should be aware of when using the increment or decrement operator inside other statements, like in this case, the println method call. If you are just incrementing or decrementing the number outside of anything like this method call, like this number plus plus, then you shouldn't have any problem at all. See? So if you ever get like unexpected values after using the increment or decrement operator in your program, just make sure that you are using it correctly or you are using it in the right place. I hope that you remember in a previous lesson I have taught you about the character type. It is one of the primitive types in Java and you can store any Unicode character in it. Like in this example, I have stored the percentage sign in a character variable called the percent sign, and I have printed out the character on my console using the standard system.out.println method. Now the character type is good and everything, but if you want to store multiple characters together, for example, your name or a sentence, you cannot use a character for that. For this type of scenarios, we have string. Now, in Java, there are multiple ways of declaring a new string. Let's see the literal way first. So instead of car, you will need to type string with a capital S and then name of the string, in this case name, and then the value. So this is my name. You can put any string right here, and then you can print it out like any other variable in Java. Let's run the code. Now the other way to declare a string in Java is by using the new keyword. The new keyword in Java can be used to create new objects from classes. Now, we have not discussed classes at all in this course yet, but we will get into classes and objects and object-oriented programming later on. For now, just remember that the new keyword can be used to create a new object from a class. Now, to create a string using the new keyword, you will have to write string, then the name of the string equals new string and the value. If you run the program, there should be no change whatsoever, because essentially declaring the string this way or that way doesn't make any visible changes to the program, but there is a slight difference in these two techniques. Now, the JVM, or the Java Virtual Machine, usually uses a portion of your computer's memory to store strings. Now, this little portion of memory is usually called the string pool. Now, whenever you create a new string in the literal way, Java will first check whether this string, Farhan Hassin Chaudhary, already exists in the string pool or not. If it does, then the JVM will simply reuse that previous string with a new name. But in case of the new keyword, the JVM will create a new object regardless of whether this value already exists in the pool or not. I think this can be demonstrated with an example very well. Now, for this, I will create 4 strings. First one, string literal string 1 equals to ABC. And I'll create another literal string with the same value but different name. There you go. Now I will create 2 object string. I mean, don't get me wrong, these strings are actually same, but I am just naming them as literal string and object string to make clear that which is what. Now object string equals to new string, maybe EFG or XYZ. So I'll make a copy of this string, change its name to object string 2 with the same value. Now if I compare these 4 strings with each other like this, .println literal string 1 equals literal string 2, and I'll make a copy of this line and use object string instead of literal ones. Sorry. Let's make this wider so that the code becomes easier to read. And now if we run the code, as you can see, when declaring a new string using the literal format, since the value ABC was already present in the string pool, the JVM actually reused the older value with literal string 2. But when using the new keyword, even though the same value has been assigned to the 2 string variables, they are not same. You have already learned that the double equal sign checks whether 2 objects are same or not, and in this case the literal strings are actually same since they're using the same value from the pool, and the object strings are different entities because they are not reusing the same values from the pool. Now, depending on your necessities, you may go with either of these techniques, but I would suggest that you go with the literal string technique if there is no problem with that, because this will not only make your code easier to read, there is no new or there is no duplicate string written in the code, but also it will let the compiler optimize your code a little bit. Now, the strings in Java are not primitive types. These are object types, and the strings are literally one of the most powerful types in Java. You will use strings a lot throughout your entire programming career, and there are a lot of methods that we can use with strings. So now I will demonstrate a few of those essential methods that you can use on strings and do fancy things with this. Depending on the type of software you are working on, you may or may not have to work a lot with string formatting. Now, let me explain this topic with an example. First, I would suggest that you go back to the stacked layout from side by side, because now our code will get a lot longer sideways and not vertically. Okay, let's begin by removing everything and writing a single system.out.println statement. And in here, we will write a pretty long sentence this time, which is hello world. I am Farhan Hassin Chaudhary. I am from Bangladesh and I am 26 years old. Very simple program. If we run it, yeah, so you're getting the entire line without any changes. Now we can take out a bunch of stuff from this line, such as my name, then my country name, finally my age, now to use these variables inside this string, you can use the plus sign. You may have already seen example of using the plus sign to like slot in dynamic variables inside strings. You can do the same here. So I'll get rid of Farhan Hassin Chaudhary and end the string here. So now the first string starts here and ends here. The second one starts here and ends right here. And in between the two strings, I'll put my name. Next, I can take out the country name as well. So I will separate the strings, put two plus signs and put country in here. Nice. Finally, the age. Same drill. Separate the string to plus signs and the variable name. Okay, let's save the code, cross our fingers and run it. Yeah, as you can see, the output is fine, but I hope you are getting a sense of how complicated this string can get once you start adding more variables, such as if I add my company name, the company you work for, company equals, let's say, Free Code Camp, a really nice place to work at. So I can change it to I work for, and then plus company. Now you can put plus and a dot. Yeah, works just fine. So the point I'm trying to get through is the fact that as your string grows and you start to use more and more variables in it, using the plus sign to concatenate strings or add them together becomes really clumsy. There is a better way to do this, and that's formatting your strings. So let's declare another string called formatted string equals, then we will write string dot format. So my name is modulus s. I am from modulus s. I am modulus D years old, and I work for modulus S. So once we have written this line, we will say comma. So my name is modulus S. So this modulus S or modulus D, these characters are called format specifier. So when the Java compiler comes and reads your line like this, my name is modulus S, the compiler knows that there will be a certain string here. And when it reads, I am modulus D years old, the compiler will know that there will be an integer number here. But the compiler doesn't know yet what string or what integer value will replace these format specifiers. So once you have finished writing your string along with the format specifiers, you will have to put a comma and then put in the variables in the same order of the format specifiers. For example, we have my name is modulus S, and we want to replace this part with the name variable. So we will put name. Then we will put a comma, and then I am from modulus S, and we want to replace this format specifier with the country name. So country, comma, then we have modulus D, which we want to replace with the age. Finally, we have one more modulus S that we want to replace with the company name. Let's put a full stop here. There you go. Now we have a formatted string. So instead of writing this long string with plus signs and variable names and whatnot in it, we can just write formatted string. Let's run the code. And as you can see, it works out just fine. So far, you have seen the format specifiers for strings and integers. There are also certain format specifiers for floating point numbers and booleans. So the format specifier for a floating point number, be it a float or a double in Java, is modulus F. So if I put in a double here, like maybe by GPA equals 3.8, this is not real, and I can write my GPA is modulus F, and we can replace this modulus F with the value of GPA. Excellent. Finally, the format specifier for a character is modulus C, and a boolean is modulus B. Now, I can't think of any fun example to demonstrate modulus B and modulus C, but I'll just go with it, okay? Maybe character percent sign equals to, put the percent sign here, and I can say I have attended 100% of my university classes. Excellent. And after the GPA, I can just use a comma and put percent sign here. Cool. Then let's put a boolean as well. Boolean, am I telling the truth, equals false. No, I'm not telling the truth. I haven't attended 100% of my classes, and my GPA is also not 3.8. So Am I telling the truth? You're right. These are all modulus B claims. And I can put a comma here. And then, am I telling the truth? Yeah. That's a really horrible name, to be honest. Let's run the program again. Excellent. My name is Farhan Hassin Choudhury. I am from Bangladesh. I am 26 years old. I work for Free Code Camp. My GPA is 3.8. I have attended 100% of my university classes. These are all false claims. So as you can see, the string.format method returns a formatted string by replacing all the specified format specifiers with your given values. Now, instead of saving this formatted string in a separate variable like I have done here, you can actually just copy the entire thing and paste it inside the println call. Now, although it works and you can do this if you want, but I would not suggest doing this because there is something called the printf function that you will learn later on in this course that actually lets you use the format specifiers right in the print function. So for now, I would suggest that you save your formatted string in a different variable and then print that out using println, or use that however you see fit. So remember, the format specifier for a string is modulus s. For an integer number, also for shorts and longs, is for modulus d. For floating point numbers, both floats and doubles, modulus f. For characters, modulus c. And finally, for booleans, modulus b. While working with strings in Java, it's really common to check the length of a string, or you may want to check whether a string is empty or not. Like a lot of things in Java, doing these two tasks is really easy. Let's start with a single string, okay? So string name Farhan Hassin Choudhury. Now to check the length of this string, you can write first the name of the string, which is name, then dot length. The length is a method that remains inside every string that you create in Java. Now, if you run the code, as you can see, the length of the string is 22, which means there are 22 characters in the entire name, including the spaces in between, okay? Now, you can also check whether a string is empty or not. To do so, you can just write the name of the string, which is name in this case, and then dot, and is empty. This is another method that returns either true or false. If the string is not empty, then it will return false, and if it's empty, then it will return true. Let's run the code, and the output in this case should be false, since the string actually contains some characters in it. Now, if I get rid of the name inside the string and just put two quotation marks with nothing in between them and run the code again, this time the string will be treated as an empty string and the output will be true. Now, the length and the is empty methods can be pretty useful in certain scenarios. So I would suggest that you remember them and practice their usage as you go along. You can also convert strings from lowercase to uppercase or uppercase to lowercase in Java. To do so, first you will need a string. Then To convert this string to uppercase, you just need to write the name of the string, which in this case is name, then a dot and two uppercase. This is a method, and if you run this program, you will see that the name has become uppercase. However, you may think that this two uppercase method has actually changed the original string, which is not true. So if we add another println here, printing out the original name, you will see that the original name variable is actually unchanged. You can also convert the name to lowercase by using the to lowercase method, and this will convert the entire string to lowercase. There you go. In a previous lesson, I have taught you two ways to declare new strings in Java. There was the literal way that usually reuses the string value if it's found in the string pool, and then there was the usage of the new keyword. And I hope that you also remember that when you created a string using the new keyword like this, equals to new string, and the value can be something like ABC, then make a copy of it and put string 2 with the same value and try to compare them using the equals operator or the equality operator like this. System.out.println string 1 is equals string 2. You will see that the output of this operation comes out as false. This is because even though the value of the two string is same, these are not the same object. And the equality operator usually checks whether the object on the left side is same as the object on the right side, or the object on the right side is same as the object on the left side. Now, to compare strings, you will have to instead use the equals method. So you will first write the name of one of the strings, then equals and string 2. Let's run the program once again. And this time the output is true. However, if you change the second value of ABC to capital ABC, sure, the output will be false this time since the values are not same. But there can be cases where you want to check whether a string is equal to another string or not, ignoring their cases. So for those scenarios, you can use the equals ignore case method instead of the regular equals method. So as you can see, even though the two strings have different casing, the output is still true. You can also replace a part of a string in Java. To do so, first you will need a string such as the sky is blue, and then say for example we would like to replace the word blue with red here. System.out.println string, which is the name of our string right now, and then you'd like to replace the word blue with red. Then run the program and see what the output is. As you can see, the word blue has indeed been replaced with red. Now you may think that the replace method changes the original string, but it doesn't. There you go. What it actually does is it replaces the word blue with red in the string and returns the updated string as a new one. So instead of putting it directly into the println method, you can also do something like string updated string equals to this, and then put updated string inside the println method. So this will give us the same result as before. You may not always want to replace a substring within a string, but you may want to check whether a string contains a certain word or substring or not. You can do so in Java as follows. So we will use our previous string which says the sky is blue, and we will check whether this string contains the word sky or not. To do so, you will say string, which is the name of our string here, then a dot, and then contains, and you will need to pass the string that you want to check for to the contains method. In this case, it's sky. Save the code and run it. Since the string contains the word sky, the output is true. But if you put something that is not present within the string, such as free code camp, and run the code, the output is false. Back when I was learning to code for the first time, one of the things that I learned and it gave me a sense of achievement was being able to take input from the user. So far in this course, you have learned about different types of data, operators, and outputting text on the console. In this lesson, I will show you how you can take different types of inputs from the user, as well as print out text on the console in some other formats. If you are familiar with programming languages like Python, where taking input is a matter of a single line, you may be disappointed to learn that in Java, you have to write quite a bit of code to take an input from the user. Now, the first thing that you need to take input from the user is something called an scanner object. Now, scanner is one of the classes in Java, and you can use the new keyword to create a new scanner object from the class. So you begin by writing scanner, since the type of the object will be scanner, and you can name it anything, but I prefer naming it something simple like scanner. Then equals new scanner, and you will have to let it know from where you are getting the input. So since you will get the input from the console or the terminal, you will have to write system.in. Now, this scanner class that you are seeing here, it doesn't exist in your program yet. You will have to import it first. So before the first line where you declare the class, you will have to write import java.util.scanner. Now, you may be seeing this import statement for the first time here, but it's nothing complicated. There will be scenarios where a certain class will not be a part of your current program or your current class, and you will have to import it from somewhere else. So the Java language comes with a lot of such classes that can be really useful in different scenarios. The scanner class is one of them. So once you have defined the new scanner object, you can take input from the user. So first, I would like to spit out something informative on the screen like system.out.println. What is your name? And then I will end the line here, and I will say scanner dot next line That's it. Now, the scanner.nextLine method can be used to take strings as input from the user. You will have to save this input somewhere though. So you can say string name equals scanner.nextLine. Then you can print it out. Just let's print out the name for now. Okay, let's run the program and see if it works or not. Okay, as you can see, there is a squiggly line under scanner, and if you hover over it, it says resource leak scanner is never closed. Well, what it essentially says is once you are done with the scanner, you will have to close it. It's like an open door. So if you do not close it, it will be active on the memory. So you will have to go like scanner dot close, and this squiggly line should go away. Yes, it did. Yeah, now the program is fine. Let's run it. Yeah, what is your name? Okay, Farhan Hassan Choudhury. Enter, and yeah, it prints out my name pretty nicely. Now, you may notice that inputting my name after the prompt, like what is your name, then inputting my name in the next line may look a little bit weird. So instead of using the println method, what we can use here is the print method. So the print method is actually similar to the println method, but the main difference is that it doesn't have a new line character at the end of the line. Let me show you. So as you can see, now the text prompt is right after the question mark. So I can say Farhan. Yeah, enter. And yeah, that's nice. Now, in case of a println method, there is usually a new line character at the end. So this causes the text cursor to go to the next line. Let's run the code to see how it changes our output. Yeah, as you can see, now it mimics the behavior of the println method. Okay. Now, apart from the print method, there is another useful cousin of this println method called the printf. In a previous lesson, I have showed you how you can create formatted strings using different types of format specifiers. And I also told you that there is a variation of the println method that lets you use these format specifiers right within the print method. Okay, that's the printf method or print formatted. Now, instead of just printing out the name like this, we can say hello modulus s, how are you? And then we will put a comma, and we would like to replace the modulus s with the name. So we will put name. I hope you remember all the different format specifiers that you have already learned about. If not, you can just go back and rewatch that lesson. Let's run the program again. Farhan Choudhury. And yeah, now the program greets me and also asks, how am I? Okay, let's do something more. So you have learned that the next line method usually gives back a string from the user, but you can also ask for specific data types such as maybe an integer. So to do so, let's modify the next printf here. So hello Farhan, how old are you? Okay. And then we would say int age equals to scanner dot next int. Okay. Yeah, nice. And we would like to print out system dot out print ln. Yeah, and sorry, not println, printf modulus d is an excellent age to start programming. Okay, like any age is like excellent to learn programming, so you know. And we will put age here, so this modulus d part will eventually be replaced by the age variable. Okay, let's run it. What is your name? Okay, my name is Farhan. How old are you? 26 maybe? Yeah, 26 is an excellent age to start programming. Nice, I like it. Okay, now so far so good. Like the next line method and next int method, there are also methods for double, like scanner dot next double and next float and all those different types that you can think of. But one thing that I would like to draw your attention to, and something that catches a lot of Java beginners off guard, is a little quirk. So as you can see, I am asking for the name using the next line method. Then I'm asking for the age using the next int method, and it works out just fine. But let me show you what happens if I try to use another next line method after this next int method, okay? So if I say system.out.println or printf. Okay, let's just reuse this line. Okay, it's an excellent age to start programming. What language do you prefer? Yeah. Yeah. And after that, we'll say string language equals to scanner dot next line. Okay. System.out.printf modulus s is a very popular programming language. Put a full stop, semicolon, scanner.close. Yeah. Now, sorry, I missed the language here. Yeah. Now look carefully what happens when I run the program. Okay, so I run the program. So first it asks for my name, which is Farhan. After asks how old am I, so 26. And then it skips the last prompt where I'm asking about the programming language preference and just ends the program abruptly. And the worst part is there is no error or no failure at all, which can help you to debug this problem. Well, this is something, this has to do with the way the next int and the next line method works. So let me explain. So when you are saying string name equals to scanner.nextLine and I'm inputting my name, then I'm pressing enter, the next line method is actually taking the entire name along with my enter or my new line character at the end or the carriage return. When I press enter, that goes as an input. But when it comes to the next int method, it only takes the number or 26 as an input and leaves the new line character or carriage return in the buffer, in the input buffer. So what happens is when I say 26 and then I press enter, this part will be consumed by this method next int, but the enter will be left in the input buffer. So when the second next line call comes, it sees that there is already an enter in the input buffer and mistakes it as a enter key press from me. So it assumes that the user has already inputted the text they wanted to input and ends the call right there. Okay, I hope it makes sense. Now, there are multiple ways to deal with this problem, and one of the ways is whenever you put a next int call or next double call or next float call, whatever it is except next line, then you will have to put an extra scanner.next line here. So this just cleans up the input buffer. So this next line method eats up the enter that was left by the next int and cleans the input buffer. So if we run the program now, okay, let's say Farhan, and how old am I? 26. What language do you prefer? Well, Java. Yeah, Java is a very popular programming language. Cool. So this is something that you should keep in mind, that whenever you are using a next int call, anything but a next line call, and you want to put another next line call after that, like we have here next int and then next line, you will have to put an extra scanner.next line call just to clean up the input buffer, just to get rid of that leftover enter press. Okay, otherwise your program may skip the next call. Okay, another way to deal with this situation is, instead of using methods like next int or next float, you can just use next line for taking all the inputs, and then once you have taken an input, you can just convert it to something else. Okay, for example, instead of using the next int, if we use the next line method here, and this will give us a string. So what we can do is we can say integer dot parse int and then put the scanner dot next line in there. Okay, and let's run the program and see what happens. 26 and Java. Yeah, it works out just fine, and we do not have to use any extra scanner objects as well. Now, if you had instead of int, you may have double here. You can do so. Double, say for example, if we want to take the GPA of the user equals to DOUPL double dot parse double and then scanner dot next line, and this will work out too. Okay, so all of the parse method that we have in these classes, like integer dot parsing, double dot parse double, we can use all of this. Now you may think that how would I know which method to use when you are trying to parse a number from a string? Well, one way that I suggest everyone is you can just Google it, saying how to parse integer from a string in Java, or maybe how to parse a double from a string in Java, and so on. Well, this is something that I would leave up to you to figure out, because this is something that you do not learn in courses. Okay, so I hope you have learned about taking inputs from the user. The main thing you need is a scanner object, and you will have to let it know from where you are getting your input. You can also take input from a file and some other places, but those are a bit advanced for what you know at the moment. And you will also have to remember to import the scanner class first, otherwise the code will just fail. Okay, if I comment this out and run the code, you will see the program simply fails to find the scanner class. It says cannot find symbol. So make sure that you have imported the class at the top here. And the rest is pretty simple, I guess. So now that you have learned about taking input from the user and outputting text on console using printf, print, and println, in the next lessons we will learn about something called the conditional statements, and we'll make a very simple calculator project that will just show you how much you can do with what you have already learned. Now, you have already learned about the logical operators and taking input from user, two of the most important things in programming. In this lesson, I will teach you something called conditional statements that lets you make logical decision based on some conditions and branch out your code in different ways. For example, we will make a calculator in this lesson and we will let the user perform addition, subtraction, multiplication, and division operations based on their inputs. So first, we will need a scanner, of course, and let's get rid of all this code. Okay, yes, we need to close the scanner as well. Okay, let's begin with a double. Double number 1 equals to scanner dot next double, and then we will also do number 2 scanner dot next double. We need to output something on the screen as well. Println, sorry, let's use print here. Enter the first number. Okay, and then we'll put enter the second number. Yes, and let's just output the numbers to make sure that the input is working fine. Number 1, and then let's make a copy of this line. Number 2. Yes, let's run the code. Five and 10. Yeah, looks like the input is working fine. Now we will need to ask the user what operations they want to perform. For that, let's spit out what operation do you want to perform. And okay, we will use print instead of println. And then we will have to take a string input. So string operation equals to scanner dot next line. So as I have already told you that these next double calls will leave 2 next line characters in the input buffer, so we will need to clear them out first. So let's just put this extra calls here. And once we have taken the string operation, then we can check what it is. Okay, so the if statements in Java or in programming in general lets you check whether a certain value meets a certain condition or not. For our case, we can say if, then a set of parentheses, operation dot equals sum. So if the user has written sum as the name of the operation, then what you want to do is system.out.println, and we will say not println, printf modulus d plus modulus d equals to modulus d, comma. So we want to replace the first modulus d with number 1. This should have been f actually, since we are working with doubles here and not integers. Then number 2, finally number 1 plus number 2. Space them out in the line with a semicolon. Excellent. Now let's check out our simple calculator and see if we can do the summation correctly or not. So the first input will be 5. You can put anything you want. The second number will be 10. What operation do you want to perform? Okay, sum. Yeah, 5 plus 10 equals 15. Now what happens if I put anything but sum? Okay, for now we are checking if the operation is equals to sum or not, and this will return true. If it returns true, then the line inside the if statement will be executed. But what happens if we input something else? Let's check it out. 10 to maybe subtraction or sub. You see nothing happens. So for situations where an if statement fails to fulfill the condition, we can put an else statement. And we can print out system.out.println printf modulus s is not a supported operation. And we can put a semicolon here and we can say comma operation. Let's see how it turns out. Okay, 5, 10, sub. Sub is not a supported operation. Excellent. Now, I have already said that we will implement summation, subtraction, multiplication, and division. For that, what we can do is we can put else if statement here. So, if this condition fails, we can say else if, and we can put another condition here. So, operation dot equals sub. Then what do you want? Copy this line, put it here, change the plus sign with minus, and also change the operation here, minus. Then we'd want to close this gap, make it look good. So now what will happen, the program will ask for the first number, then the second number, then ask for what kind of operation the user wants to perform. And then first it will check if the operation is equal to sum or not. If it's equal to sum, then it will print out the sum of the two numbers. If it's not the sum, then the ladder will check whether the operation is equals to sub or not. If it's sub, then it will perform the subtraction operation and give out the value. And if the operation is not sum and also not sub, then it will go into the else block and print out that this is not a supported operation. Let's check it out. Okay, 5, 10, sub. Yeah, minus 5, since the second operand is larger than the first one, the value is negative. Similarly, we can just implement the multiplication and division operations. So let's just do them. Else if operation dot equals multiplication, then I'll just copy this entire line and yep, and yeah, that's it. Finally, the division operation is a little different. Operation equals to div. Then first we will have to check. We'll put another if inside this else if, and this is called a nested if block. So we will check if number 2 is equals 0. Then we want to print out system.out.println cannot divide by 0, because you just cannot divide a number by 0. And then we will put else and we'll perform the division inside. And we'll bring up the else block here. And now let's check out the division and multiplication operations as well. Let's put 10, 0, and div cannot divide by 0. Excellent. Let's rerun the program. Enter the first number 10, 2, div 5. Excellent. Finally, the multiplication operations. 10, 8 mul or multiplication. Yeah, 80. Excellent. So we have already managed to create a very simple calculator here, capable of performing the basic arithmetic operations using if-else. Now, I'm not saying that this is the only way to implement a calculator. You can actually find even much better ways of making calculators. But so far, what you have learned, this is a pretty good implementation of all your knowledge. Now, when it comes to branching out your code based on one or more conditions, if-else statements are pretty common. But this is not the only way of doing things. There is another statement called switch case statement that can do the same thing as a complicated if-else ladder. In this lesson, we will convert our calculator application to use a switch case statement instead of if-else statements. Now, before we dive into our code, I would like to go to settings and change our layout from stack to side by side, because as I'm seeing, our code is becoming much longer vertically and it's becoming harder to read. We can also make the console smaller for now because we need to focus on our code. Now we can retain most of our code from our previous example. We can keep the scanner, the inputs for number 1 and number 2, the input for the operation. And the only thing that we need to get rid of is the if-else statements. Now, instead of removing the code entirely, what I would do is I will just comment it out. Now, to write a switch case statement in Java, you will have to begin by writing switch, and then within a set of parentheses, you will have to put the variable that you are trying to test. So if you remember from our if-else statement, we are testing out the value of the operation variable and see whether it matches one of the 4 operations or not. So inside the switch, put operation. Then we will put a set of curly braces. Now you may have already guessed from the name of switch case statements that there will be multiple cases inside a switch. Now these cases are like these individual if statements where you are checking the value of the operation variable against something. So in the first case of this statement, we will check whether the value of the operation is sum or not. To do so, you will have to write case and then the value you want to check against, which is sum in this case. Then you will put a colon here. And on the next line, you can put the logic for the summation. So I will just copy the code from our previous if-else ladder and put it here. Okay, let's run the code and see what happens. Okay, enter the first number. I input 5, enter the second number 10, and sum. Okay, it says 15, which means it works. Now try to put a value that is not defined within the switch case statement, like sub. Let's rerun the program. 5, 10, sub. And as you can see, just like the if statement, when you didn't have an else here, it doesn't print out anything at all. Now, in case of switch case statements, you do not have else, but you will have a default case, which you can write as default. And then you can just print out that this is not a supported operation. Yes. Let's run the program and see what happens. First number 5, 10, and sub. Okay, sub is not a supported operation. Fine. Now, so far, this looks okay, but let me show you a problem here. If I run the program, if I put the numbers and then say sum, you will see the program not only prints out the summation of the two numbers, but it also prints out is not a supported operation. Well, the way switch cases are designed that if one of the cases match, then the program will not only execute that case, but also the cases that comes after that. To stop the program from going through all the cases here, what you will need to do is you will need to use the break step. So when the program comes and it sees that the sum case has been matched, it will execute the logic here, and then it will encounter the break statement and break out of this entire switch case statement. Okay, and it will go directly to scanner.close. Let's test it out once again. Sorry. Let's put 5, 10, and sum. So as you can see, it prints out the sum and breaks the program right there. Okay, that's cool. Now, you can actually define the other cases, such as case, sub, and we will of course take the subtraction logic from our previous if-else ladder, put it here, put the break statement in. Let's just copy this, paste, okay. So the third case would be the multiplication case, and we'll change the minus signs with the multiplication sign. And finally, the division case. Now, I hope that you remember that we also had a check to make sure that the user is not trying to divide by 0. We will have to do that as well. And for that, we do not have anything fancy. We will just need to rely on plain old if-else statement. So we will write if number 2 is equals 0, then we would like to print out cannot divide by 0, else we would like to perform the division operations. Keep in mind that you should write the break statement outside of both the if and else block. Otherwise, if you put the break inside the if or the else, then it will only work if one of them are active. But if you put it out here, no matter what happens in this if else block, the break will always work. Let's try it out and see if it works or not. Save the code and run it again. Okay, 10, 0, and div cannot divide by 0. Okay, let's rerun the program and check if the normal division function works or not. 10, 2, div. Yeah, it works. Finally, let's check the multiplication. 10, 5 multiplication. 50. Yeah, it works just fine. Now you can get rid of the commented out if-else statements. Now, although if-else statements and switch case statements more or less do the same thing in the context of Java or in the context of other programming languages as well, a switch case statement is actually faster than an if-else ladder in Java. So if you can put your logic within a switch case statement instead of a really elaborate if-else statement, try to do that. So far in this course, you have only stored single values in single variables, but there is a way to put multiple values within a single variable. These are called arrays. Now, before I start working on arrays, let's do some cleanup. You can get rid of more or less everything in our code. You can also get rid of the Java util.scanner. Now, to declare a new array, for example, if I want to declare an array of characters and I want to store all the vowels in English alphabets, you can do so like this. First, you will have to type out the type of the array, which in this case is char or character, space, then the name of the array, which will be vowels, and two square braces. Then you will put an equal sign and new char. Then you will put another set of square braces, and inside of these square braces, you will have to put the length of the array. Now we know that there are 5 vowels in the English alphabet, so you will put 5. Now we have an array of characters, but it's completely empty. To insert a new value to this array, you will have to write vowels and then an index of the array, which in this case 0, then equals, then the value you want to save in the array, A. Now, I have already told you that this array is of 5 length, which means it can store 5 characters in it. Now, these characters here can be stored like A, E, I, O, U, and each of these characters will have a number associated with them. This number is called the index. Now, the first index of an array in Java is always 0. So by putting vowels and 0 inside a set of square braces, you are essentially addressing the first place in this array. Then you put equals A and you fill it up. Now the other spaces are still blank. Now you can copy this line and paste it to insert the other values as well. So 0, then 1, then index 2 will be I, index 3 will be O, and finally index 4 will be U. Now you have completely filled this array with the 5 vowels of English alphabet. You can also print out these individual vowels using the same square brace syntax. So if I copy vowels 2 from here